Hello, in today's video we're talking about how to prove triangles similar. So our last video was on similar polygons, and of course our favorite polygon in geometry is a triangle. So today is all about proving triangles similar. So we're going to start off, we have a postulate, and it is called the angle-angle similarity postulate, and we abbreviate it with an AA and a little squiggle. So if we write it in a table proof, this is the notation we would put in our statement column. AA squiggle. And it says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. All right, so what does it mean to be similar again? Remember, that means that the sides are going to be proportional. Okay, so our first example says explain why the triangles are similar. So they give us one set of congruent angles, and remember vertical angles are congruent, so now I have another set. So I would say since angle WSR is congruent to angle BSV by vertical angles, then triangle WSR is similar to triangle BSV. Got to make sure my angles go in the correct order. Yep. Okay. By angle-angle similarity postulate. Okay. And then it says write a similarity statement. Well, I wrote my similarity statement right there. So triangle WSR similar to triangle BSV. Okay. So the next thing we have is we have two theorems based on this, and we are not going to prove these theorems. I will do a separate video of the proofs, and you can watch that later, so that'll be uploaded later today. But we're not going to prove these. We're going to skip over proofs. Aren't you excited? So the first one is the side angle side similarity theorem, and it says if an angle of one triangle is congruent to an angle of a second triangle, and the sides, including the two angles, are proportional, then the triangles are similar. Okay, so you might be asking, what does this mean? What would this look like? So if I have two triangles, let's make them look at least similar. Yeah, that looks good. Okay, and an angle of one triangle is congruent to an angle of a second triangle. So let's say this angle is congruent to this angle. And the sides including the two angles are proportional. Okay, so the sides including the two angles are proportional. So let's say this is A, this is B, this is C, this is D. That would mean that to be proportional, if I compare A to C, that's going to be the same thing as comparing B to D. Okay, so that's what it means for my two sides to be proportional. Or you could even do it within a triangle. So I could say A to B is equal to C to D. Okay, so that's another way of doing it. So either of those proportions would work. All right, our next theorem is called the side-side-side similarity theorem. And so it says that if the corresponding sides of two triangles are proportional, then the triangles are similar. So if I use my same two triangles up there, let me redraw them here. And now we're talking about all three sides. So let's label my sides A, B, and C. And then we'll do D, E, and F. And so this says if the corresponding sides are proportional, then the triangles are similar. So if I compare my sides, so A would compare to D, C would compare to F, and B would compare to E. So if I set up a proportion, an extended proportion, I would say A over D would equal B over E would equal C over F. Okay, and so if that's true, if all three of those are reduced to the same fraction, then those two triangles would be similar. Okay, so the rest of the video is examples, and so if you would like to pause the video, try the examples on your own, and then see how you did. All right, the first one says, explain why the triangles must be similar and write a similarity statement. Okay, so I look at this and I see an angle, but not another angle. So I can't do angle, angle, but I have two sides on either side of that angle. So I'm going to go with the side angle side. So now we have to check. We have to check that our sides are proportional. So I'm going to compare my small triangle over my big triangle. And I'm going to make sure I do my corresponding sides in correct order. Hold on one moment. My dog is chewing a sock and I don't want holes in my socks. Great. I saved the sock. Fantastic. Puppies, man, they chew everything. Okay, so then small triangle, and we're going to do side. We could do the short side first, and then we'll do the long side. Okay, so short side, and then long side. All right, so for my small triangle, the short side is 3. On my big triangle, the short side is 4. On the long triangle, or on the small triangle, the long side is 6. And on the big triangle, the long side is 8. So the question is, are these two equal? And yes, they both reduce to 3/4. Okay, so yes, they're equal. So I would say yes, triangles are similar. So triangle QRP similar to triangle XYZ by the side angle side similarity. All right, next, C says, explain why the triangles must be similar and write a similarity statement. So I can't use anything with an angle in it because I know nothing about the angles of these triangles. So I am going to use possibly the side similarity. So I like to go through and highlight my sides. It's kind of hard because these are isosceles. So technically, these two sides can be similar to any of the other two sides. So let's look at this. So if I set this up, I would have 6/8 twice, right? We know that equals itself. Great. And then the question is that equal to 9/12? All right. So if I reduce those fractions, I reduce to 3/4. And over here, once again, I reduce to 3/4. So they are all equal. So they all equal 3/4. So yes. Okay, so they are similar by the side postulate. And I would say triangle ABC is similar to triangle EFG. Okay. Next, let's try this next example. So the next example says find the length of DE. All right. So let's see if our triangles are proportional. So I have vertical angles. So right here, I know that this angle is congruent to this angle. And so I'm going to check using a proportion to see if those triangles are similar. And if they are, I can use that ratio to then figure out the length of that third side. Okay, so let's check. So I want to compare 24 and 18 to 12 and 16, and I'm going to make sure I compare the shorter one, so the 12 to the 18, because those are both the shorter of the two sides, and then I'm going to compare 24 to 16, okay? So let's check here. So does 12/18 equal 16/24? Okay, let's see here. Let's reduce. We can reduce by 6 on the first fraction. So then I get 2/3. And I can reduce by 8 on the green fraction. And I also get 2/3. So yes. Okay, so now we know our triangles are similar. So this helps me. Triangles are similar by the side angle side similarity. Okay, because my sides are proportional. So now I can use that 2/3. So 2/3 went from small triangle to big triangle. And so I can use that to say, hey, when I look at this, my small triangle has a length of 10 and DE is the length on the large triangle. So now I have a proportion to solve. So now I need to solve, let me pick a different color. Sorry about all the colors. I don't know if you guys like all the colors, but I do. So now I know that 2/3 needs to equal 10 over the length of DE. I can cross multiply, so I get 30 equals 2 times DE. And then I'm going to divide both sides by 2. And I get that 15 is the length of DE. Okay? Okay, once again, find the value of x in the figure. So this one, we know that the triangles are similar. So for E, they are similar by the angle-angle similarity. Great, that's nice. So now let's figure out which sides are corresponding. So I know the 6 is going to correspond to the x because it's between the angle with one arc and the angle with two arcs. And then the 12 and 8 are also corresponding. So if I set up a proportion, I'm going to put 6 to x equals, so I went from small triangle to big triangle. So I'm going to put 8 to 12 over here, cross multiply, and I get 8x equals 6 times 12, which is 72. Divide both sides by 8, and I'm going to get x equals, oh, what is 72 divided by 8? 9? Yes, 9. Okay. All right, next. We have in sunlight, a cactus casts a 9-foot shadow. Okay, let's draw my cactus. Let's see here. Got some little artwork going on. Cactus. Go. All right, and he's got a 9-foot shadow. So here's his shadow. And that's 9 feet long. And the cactus is, oh, we don't know. Oh, we got a little person. We have a 6-foot tall person. Casts a 4-foot shadow. Oh, looks like my shadow of my cactus is not proportional, but that's okay. Let's make it shorter. 9 feet. Okay. Use similar triangles to find the height of the cactus. Okay, so I can draw a triangle here. So we always kind of assume when somebody is standing and casting a shadow that they make a right triangle. Okay, so if the sun is hitting both of these at the same angle at the same time of day, then those triangles are going to be similar. So now I can set up a proportion to figure out the height of the cactus. So I'm going to say x over 9 equals 6 over 4. Or you could say x over 6 equals 9 over 4. Either way, when you cross multiply, you're going to get the same thing. You're going to get 4x equals 9 times 6. 4x equals, what is 9 times 6? 54. Divide both sides by 4. And we are going to get, I don't know what that is. X equals, let's see here. What do I get? Where's my calculator? 54 divided by 4 is 13.5 feet. The tall cactus. Okay? All right, so go ahead, try your homework, and let me know if you got questions.